Hi, welcome to my channel. This video is an introduction to organic chemistry that will discuss how to view organic structures. We will go over expanded formula, condensed formula, and bond-line structure. So what is organic chemistry anyways? An easy way to think about it is the study of compounds that contain carbon. And carbon is really important because it can form a variety of different bonds because of its unique properties. One unique property of carbon is that it has 4 valence electrons, and I never want you to forget that. Let's go ahead and draw those in. 1, 2, 3, 4. Likewise, hydrogen has 1 valence electron. We'll color it purple. And so what might happen if carbon comes into contact with hydrogen? So we can go ahead and draw carbon's 4 valence electrons, and we'll go in and draw 1 valence electron for each hydrogen atom. And so what happens is carbon says, you got an electron, I got an electron, let's make a bond. And so you start to realize that each bond actually contains 2 electrons. So now a rule of thumb in organic chemistry to keep in mind is that one bond consists of 2 electrons. So now we can take a look at this structure called butane. You might have taken a look at butane, but you never really appreciated its symmetry or understood it very much. But now you can begin to recognize that each carbon in this structure has 4 bonds. So for instance, carbon number 1 has 1, 2, 3, 4 bonds. And that's because it's making use of its 1, 2, 3, 4 valence electrons. Chemists kind of got tired of drawing in all these hydrogens, and as you become an organic chemistry expert, you're going to find it very tiresome drawing in all these hydrogens when doing mechanisms. So they decided to create something called the condensed formula. And in the condensed formula, they condense the amount of hydrogens that each carbon is attached to. So we can go ahead and number each carbon for correspondence. So we'll call this carbon number 1, 2, 3, and 4. And likewise, we'll call this carbon number 1, 2, 3, and 4. And so if we take a look at carbon number 1 here, we notice that it's bonded to 1 hydrogen, 2 hydrogen, 3 hydrogens. And therefore, carbon number 1 here is drawn with 1 hydrogen but a subscript of 3, which indicates that carbon number 1 is bonded via 3 hydrogens. So this also becomes tedious to write out. So what organic chemists did is they created what was called the bond-line form. So in the bond-line form, you might be asking yourself, well, where's all the hydrogen and where are all the carbons? So what's going on here is each corner actually represents a carbon. So there are 4 carbons in this structure because there are 4 corners or points. If we number these invisible carbons for correspondence, we'll say that's carbon number 1, 2, 3, and 4. So you might be wondering how we might do this. So first off, we can consider this carbon number 1 to be bonded to carbon number 2. I'm sure we can all agree on that. And then we can ask ourselves, well, how many valence electrons is carbon number 1 utilizing to bond to carbon number 2? I hope you said 1 valence electron. Carbon number 1 uses 1 valence electron to bond to carbon number 2. Of course, carbon number 2 also contributes 1 valence electron, but we're just focusing in on carbon number 1 for now. So carbon number 1 is using its 1 valence electron to bond to carbon number 2. Therefore, how many other valence electrons does carbon number 1 have? And I hope you said it has 3 valence electrons other than this one. And that's because carbon always has 4 valence electrons. So it's using 1 to make the bond, and so now we can assume that it's using the other 3 to form bonds with hydrogen. So it'll form 1 bond with hydrogen, another bond with hydrogen, and another bond with hydrogen. And that's what makes it a CH3 group. So don't freak out if you can't really get this yet so quickly. With practice, you'll be able to look at bond line form and think of expanded form. It might take a little bit of time. So with carbon number 2, we notice that it's bonded to carbon number 1 and carbon number 3. And so how many valence electrons is carbon number 2 using to make those two bonds to the carbons? So it's using 1 electron in this bond and 1 electron in that bond. And therefore, how many other valence electrons does it have? It has 2 more, because remember, carbon has a total of 4 valence electrons. And therefore, it's using those other 2 valence electrons to bond to hydrogen. That is what we assume. And that's what makes carbon number 2 a CH2 group. And so you're going to begin to start seeing this in your head. So carbon number 3, we see, has the same scenario where it's bonded to 2 carbons. And therefore, it's using 1 electron to bond here and 1 electron to bond here. And therefore, it has 2 more electrons left. And so what happens is it's going to use those 2 electrons to bond to hydrogen. And that's what makes carbon number 3 also a CH2 group. And with carbon number 4, you notice that it's bonded to only 1 other carbon, which is carbon number 3, and it's utilizing its 1 electron to do that. And so therefore, how many other valence electrons does it have left? And I hope you said 3 valence electrons. And therefore, we can assume that with those 3 valence electrons, it will be bonding to hydrogen. And that is what makes carbon number 4 a CH3 group. So now we're going to take a look at converting bond line formula to condensed formula and vice versa. Look at each point on this structure. And remember that each point I said represents what? Each point represents a carbon. Therefore, the structure here has 4 carbons. So if we take a look at carbon number 1, we notice that it's bonded to carbon number 2. And we know that carbon number 1 has 4 valence electrons. So 1 of those electrons are being contributed to this bond. Therefore, carbon number 1 has 3 more valence electrons. And with those 3 valence electrons, what we do is we assume that each one is going to be bonded to a hydrogen. Therefore, carbon number 1 has a CH3 group. What about carbon number 2? Carbon number 2 we see is bonded to carbon number 1 and carbon number 3. And therefore, it is contributing 1 electron to each of those bonds. Therefore, how many electrons does it have left over? I hope you said 2 electrons, because remember we said that each carbon has 4 valence electrons. So with those 2 other valence electrons, it can form hydrogen bonds. Therefore, carbon number 2 is a CH2 group. Now, what about carbon number 3? Carbon number 3 is bonded to carbon number 4 and carbon number 2. And carbon number 3 is using 1 electron to bond to carbon number 2, but how many electrons is it using to bond to carbon number 4? So notice how in carbon number 4, it's bonded via a double bond. What does that mean? Remember how we said that each bond is using 2 electrons. So this bond has 2 electrons, 1 from carbon number 4 and 1 from carbon number 3. And this bond also has 2 electrons, 1 from carbon number 3 and 1 from carbon number 4. So therefore, how many electrons is carbon number 3 contributing to the double bond? And I hope you said it's contributing 2 electrons, because remember the carbon number 4 is contributing its other 2 electrons. But carbon number 3 is just contributing 2 electrons. It's also contributing 1 electron to carbon number 2. So how many electrons does it have left over to form a bond? And I hope you said 1 more electron. Carbon number 3 has 1 more valence electron, and so we assume that it's bonded to a hydrogen. Therefore, carbon number 3 has a CH group. So carbon number 3 is just CH. And now what about carbon number 4? So remember we said that carbon number 4 is attached to carbon number 3 via a double bond. And so likewise, carbon number 4 is contributing 1 electron to each of those bonds. Therefore, carbon number 4 has how many electrons left? 2 electrons. Therefore, carbon number 4 has a CH2 group. So now let's take a look at the next example. So in the next example here, we have 1, 2, 3, 4, 5, 6 carbons. What we do is we're going to figure out how many hydrogens are on each carbon. So let's go ahead and start with carbon number 1. So carbon number 1 is attached to 2 carbons, carbon number 2 and carbon number 6. Therefore, it's contributing 1 electron to carbon number 2's bond and 1 electron to carbon number 6's bond. Therefore, it has 2 leftover valence electrons, right? Because 4 minus 2 is 2 that it can form hydrogen bonds with. Therefore, it forms a CH2 group. So take a moment to pause the video and tell me which carbons also have CH2 groups in this molecule. Now that you've unpaused your video, I hope you said that carbon number 2 is also a CH2 group, carbon number 5 is a CH2 group, and carbon number 6 is a CH2 group. They all have the same pattern, bonded to 2 carbons, therefore bonded to 2 hydrogens as well. Carbon number 3 is a little bit different because if we look at carbon number 3, we see that it's bonded to 1, 2, 3 carbons. And therefore carbon number 3 is contributing 1 electron here, 1 electron here, and 1 electron here. And therefore, how many valence electrons does it have aside from those 3 that it's contributing? I hope you said it has 1 valence electron. And with that 1 valence electron, it can bond to a hydrogen. And therefore, it's going to be a CH group. Carbon number 4 now. Carbon number 4 is bonded to carbon number 3. And therefore, it is using 1 of its electrons to bond to carbon number 3. Therefore, how many valence electrons does it have aside from that 1 electron? And I hope you said it has 3 valence electrons. And with those 3 valence electrons, right, we assume that it bonds to hydrogen. And therefore, carbon number 4 is a CH3 group. Now, next up, we have a different looking structure. And this structure actually has an oxygen atom in it. So notice how in bond-line formula, we draw out the oxygens. Whenever you have an oxygen and a nitrogen, it's going to be drawn out in bond-line formula. We do not make any assumptions regarding those elements. If they are there in the structure, they will appear there. Now let's go ahead and put in our carbons for correspondence. And remember, we said there is 1, 2, 3, 4 carbons here because of the 4 points that we have there. And we can number them for correspondence. So now carbon number 1 is bonded to oxygen via single bond and bonded to carbon number 2 via a double bond. So here it's utilizing a single bond and here it's utilizing a double bond. So carbon number 1 is going to use how many electrons to bond to the oxygen? It's going to use 1 electron, right? And carbon number 1 is going to use how many electrons to bond to carbon number 2? 1 for each bond. And therefore, it has only 1 left to bond to hydrogen. Therefore, it is a CH group. Now, what other element here is a CH group? Or it looks similar to carbon number 1? And I hope you said carbon number 4 because carbon number 4 actually has the same chemical environment as carbon number 1, right? They're all bonded to the same things. And these are little tricks and tips and patterns that you want to start picking up on. In organic chemistry, there's a lot of talk about symmetry, and you're going to get into that a little bit later. But it's good to pick up on it. So now we can move on to carbon number 2. Carbon number 2 is bonded to carbon number 3 and carbon number 1. And it's bonded to carbon number 3 using a single bond. So it uses 1 electron there. Hold on, let me put that more on the line. 1 electron there. And now it's bonded to carbon number 1 using a double bond. Therefore, 1 contributing electron for each bond. And so carbon number 2 is utilizing 3 electrons for those bonds. Therefore, how many does it have left? And it has 1 left to form a hydrogen bond. Therefore, it's going to form a CH bond. What other carbon in this structure is similar to carbon number 2? And I hope you said it is carbon number 3. So it is carbon number 3. And now we can take a look at the next structure. So you see here how oxygen is drawn, and because I told you that with other elements such as oxygen and nitrogen, they're going to draw them into your bond line structure. So let's go ahead and number those carbons. So carbon number 1, carbon number 2. So carbon number 1 is going to have been bonded to carbon number 2, and therefore it's utilizing 1 electron, and therefore it has 3 electrons left over. Therefore it is a CH3 group, right? You just subtract it. And carbon number 2, right, is using 2 electrons. Carbon number 1 and 1 to bond to the oxygen atom. Therefore, it has 2 other valence electrons, right? So we see that those 2 valence electrons are going to be bonded to hydrogens, and therefore that makes carbon number 2 a CH2 group. So that's it for this video. If you liked it, please leave a thumbs up and feel free to subscribe. Happy studying!